Hi, my name is Nick, and this video is a walkthrough for my indie project called CodeForge, which I built as part of my enterprise Java coursework. CodeForge is a coding challenge and practice platform designed to help users work through structured challenges, submit solutions, and receive feedback, with a strong focus on backend architecture, testing, and deployment. The motivation behind this project was to build something more realistic than a simple CRUD demo. Something that mirrors how an enterprise-style Java web application is actually structured. That meant focusing not just on features, but on things like authentication, persistence, test isolation, environment configuration, and maintainability. This project was developed with a deliberate MVP scope. Rather than trying to build a fully polished UI or every possible feature, I focused on building a solid back-end foundation that could be extended later. The emphasis here is on correctness, structure, and clarity, making sure the application behaves predictably and is testable, deployable, and understandable. One thing I want to point out is the amount of planning and documentation that went into this project. In the docs directory here, I kept project plans, weekly journals, design notes, MVP definitions, and even database scheming drafts. Let's see if I can see it. There should be a schema here somewhere. DB schema. This helped me track decisions over time, adjust scope when needed, and stay aligned with the project rubric. With that context in mind, I'll start by walking through the application from a user's perspective, and then gradually move deeper into the back-end persistence layer and testing strategy. Later in the video, I'll also talk about the challenges I ran into, especially around database configuration and testing, and how I worked through them. So next for the tour, I want to start by walking through the application from a user's perspective. This is the home page of CodeForge. From here, users can browse challenges, log in, and practice and drill. And do drills. Down here we've got, for my external API, I just introduced an quick and easy quote API that just gives random quotes, which will be expanded later post MVP to include a settings on the me page for a user's home page, so that they can kind of choose what type of quotes they get hit with, and this changes every visit, just randomly. Every few minutes it gives a new quote. It's just a motivation, kind of a motivational thing. Excuse me. So, but now for authentication, authentication is handled using AWS Cognito. When a user logs in, the session is established and user context is made available throughout the application. Unauthenticated users are redirected to the login page, and protected routes require login. So for instance, drill is going to make you sign in, or trying to access CRUD. But if we just log in here, this is the me page, user page, pretty basic right now. I plan to add things in here like stats and such and stuff like that. So that's post MVP stuff that when I have time I will be adding. Anyways, so Next, we'll look at the challenge. This is the challenges list. One slot. Well, this is open to anyone. Anyone can view this. You don't have to log in to view this page, but users can view a list of available challenges here. Each challenge represents a structured coding problem with metadata like difficulty and title stored in the database. Clicking into a challenge shows its details in the associated metadata. This page pulls data from the persistence layer using Hibernate and renders it via JSP with JSTL. And it's got CRUDs, edit, availability to edit, create new challenges, and practice. This is the practice page for a specific challenge, and it gives a user the ability to practice challenges. I see this more as a tool to help build challenges for creating new challenges. I think that's what it would be most useful for here, or just maybe practicing a challenge if you got it wrong in the drill and it won't come up for a while and you want to keep practicing it for a while. I'll get to that in a minute, what that means. This is just basically a placeholder of the language. I plan to add more post MVP. And I'll show more about how this works in the drill. Excuse me. Now, as for drill, again, this is practice. This is just a placeholder for the practices, practice page, which I'm going to add better access to practice of each challenge, I think. And then this shows the drill queue, which is like the main layout, the main work area for drilling, for doing drills. And basically how this works is when the user starts, they have all the challenges in a list in the queue, and what happens is you work through each one, and you can either get them correct or incorrect, and depending on whether you're correct or incorrect will set it so that it comes back into the fold once a certain time is expired. It's longer for correct, shorter for incorrect. That way you're not stuck on one trying to get it right over and over. You move on, you try it again later once it comes back up into the queue. And then the ones that you got right don't come back for a longer period because it gives you time to work on the other ones, and but you're still drilling with the ones, even though you got them right, you might not, the more you drill it, the more it's going to really sink in. So anyways, you can start the drill. It's going to pull up the next one that's in the queue, and it's going to give you a prompt, and you're supposed to answer it within this code box. Give your answer in the code box, whatever your code is that you're answering with. It's very unsophisticated at this exact moment, but post MVP is going to have a lot more sophistication in the answer. So right now I have this hint thing. This is just for display purposes only. This is removed once I finish this MVP. And so once you get then you answer your question in the code box, and then you run submit. It's going to go to the next one immediately, to the next one, so you can continue working. But if you're done, you can go back and you say, okay, it's correct. It's removed from the queue and put on a timer. Since it's correct, it's going to not come back into the fold for a longer period of time. Now, we're not seeing any next do's here because this is the first time we've gone through these. They're not showing back up yet, and this would show up once you get back down the list to where they are waiting. And then the goal here isn't to build full online judge yet, but to establish the full request response persistence loop. Alright, now for the about page, we just got, you know, a quick overview, quick tech stack, current status, future enhancements, stuff I plan to implement, and we also have the API Java docs here, link, that we can look at the Java docs. These Java docs cover the service, persistence, and utility layers. Anything in the app. And they're meant to help future developers understand intent, not just method signatures. All public classes, including test classes, are documented to explain why they exist and how they're used. And if we look at our entities here, we can see all of the entities that we're using, some enumerations, and the authenticated user. This is a challenge. I won't go too deep here, but this documentation supports maintainability and onboarding. Alright. Now that we've seen the application full and documentation, I'll move into the backend architecture, starting with database and persistence layers. Alright, so next I'm going to walk through the database and persistence layer. I'm going to explain how the data flows from the database to Hibernate through the service to UI. And I'm also going to show that intentional design trade-offs are made. This is an MVP first, scalable later design. I'll start with the database design since everything else builds on this. So back to the schema here. The schema is intentionally small and normalized for an MVP. Code entities are challenges, drill items, and submissions. Each challenge can have many drill items, and submissions represent a user's attempt at a drill. I focused on relationships that support realistic usage without over-modeling too early. I knew I was going to be working on this for a long time afterwards, and I had to get something out for MVP, and this is what we got. Alright, for now, let's check out LiveDB from Workbench here. Alright, so here's the database itself. It's called CodeForge. We got the challenges table, drill items, and submissions. You can see the tables and foreign keys relationships. The schema is stable enough to support testing and feature growth, but still easy to reset during development. Looking at the tables a little closely here, we got challenges. We've got one for each challenge, just recording all the metadata about that challenge. Drill items. So this is basically the data for the drill itself, and it's recording things like when each challenge should return back in and show again, what kind of streak you have going on for that challenge, how many times that challenge has been seen total. Submissions, this is where every submission is kept, and there's several different possibilities, several different outcomes. We got correct, incorrect, acceptable, and skipped, and each have a different delay before it is reintroduced back into the queue. And with the submission, you also get whatever you entered as for your code, just a record of what you entered and whether it was correct or incorrect, and obviously when the submission was made. Alright, and then we'll jump over to the IDE, and I'll show you the entities. So on the Java side, these tables, challenge, drill item, submission, are mapped to entities using Hibernate. Associations like many-to-one allow Hibernate to manage relationships without manual joins in most cases. You'll also see that Lombok has been implemented here, which, if you watch my professional development presentation, you'll see how much code this Lombok really saves. I'm a fan of Lombok now and plan to implement it whenever I can. And then next we'll look at the DAOs and the persistence layer here. We'll start with the generic DAO. So, to avoid duplicating boilerplate, use a generic DAO pattern. This handles common operations like get by ID, get all, save, update, delete, and most of the CRUD, basic CRUD itself. And this keeps entity-specific DAOs small and focused. For entity-specific DAOs, most queries use criteria API, the criteria API, for consistency with limited HQL only where it's made sense for clarity. And alright, so with database and persistence layer in place, the next step is how this logic is tested and validated. In the final segment, I'll walk through the service layer and the unit and integration tests, so just to ensure that everything works end to end, just to show that everything works end to end. Excuse me. Alright, so for the next segment, I want to do the rest of the code walkthrough and the unit and integration tests. And this should prove correctness, test discipline, and architectural understanding. So before I jump in, just want to say, the app isn't just working by accident, right? Business logic is testable and isolated. The DB state is controlled and repeatable. And the logic has a place and belongs in certain areas where, like servlet, service, and DAO layers. So I'll start by showing how the backend code is organized. The application follows a layered structure. Servlets handle HTTP, services handle business logic, and DAOs handle persistence. This separation made it much easier to test each part independently. Alright, so in the service layers here, look at challenge service here right quick. Most application logic lives in the service layer. For example, this service coordinates validation, persistence, and returns values without knowing anything about HTTP or JSPs. It's irrelevant to this. This keeps servlets thin and makes the logic reusable and testable. Next we got servlets, which live in this web layer here. And if we look at challenges servlet, so servlets are responsible only for request handling. Like parsing parameters, invoking services, and forwarding those results. They don't contain business rules or persistence logic. This also made servlet testing much simpler. Alright, and then now we'll take a look at testing. Move over to test here. And testing was a major focus for this project. The goal was predictable, isolated tests, especially when working with a real MySQL database. So we have utilities that run for the testing. The database class, which is making the calls to the database and handling the database logic. DB reset, this resets the database before each test is run. And we have the database reset SQL file, which wipes the database and then reseeds it with, fake data, seeded data. And then before each test class, the database is reset to a known state using a single reset utility. This avoids test independence and makes failures easier to debug. For an example test, let's use a DAO. We'll do challenge DAO test just to keep it on the challenge level. Here's an example DAO test. Each test focuses on one behavior, such as retrieving by ID or filtering results. Because the database starts clean every time, test outcomes are deterministic. All test classes are documented with Javadoc to explain intent, not implementation. Alright, finally, and then what I'll do finally is I'll run the whole test suite. This confirms the persistence layer, services, and servlets all work together as expected. There's quite a few of them, so it's going to take a second here. Alright, and as you can see, we've got all greens. We look at coverage and more than 80% in most. It looks like, my JSPs, or my web package, my servlets, could use more coverage, but I've got pretty good coverage everywhere else. Alright. And then overall, the focus of this project was correctness, clarity, and maintainability, not just getting something to run. I'll finish by briefly reflecting on challenges and what I learned about this in the next segment. Alright, and so for the last segment here, I'm going to talk about the deployment of the app, some of the challenges I faced, and what lessons I learned. So really, before wrapping up, I just want to talk briefly about deployment here and environment setup. Because this project was actually deployed to AWS, and that introduced real-world constraints. CodeForge is deployed using Elastic Beanstalk with a MySQL database running on RDS, and configuration is driven through environment variables rather than hard-coded values in the app, which you can see here in the environment properties area. One big takeaway here is this. Enterprise applications don't usually fail because the code is wrong. They fail because the configuration is wrong. Alright, now and I mean, you can actually see that reflected in how this project evolved. So here's the commits that I made for this project. Just a quick look here. There's many pages. I made a lot of commits on this. The commit history shows steady iteration, small fixes, refactors, configuration changes, not one big final push, right? Small atomic commit. I could have potentially been more atomic, but pretty atomic. And so I also tracked my time throughout the semester, not just for grading, but to stay honest. And I used a app called TimeLog. I used it for some of my other projects as well, but you know, I got a pretty decent time log here. A lot of that time wasn't writing new features. It was spent debugging environments, aligning configs, and making sure tests, local development, and production didn't interfere with each other. And this also ties into direct instructor feedback, which in checkpoints we'd get feedback about what we can improve, and I worked on a lot of that, fixing many things that I needed to fix, that I should have done better in the beginning. When you have time, when time's not on your side, it's not always the easiest to do. I've definitely learned a lot about time management in this semester. But several changes I made in the project were just responses to feedback, especially around simplifying configuration and making behavior more predictable. That deployment reality really set the stage for the biggest challenges I faced, which wasn't just writing code, but understanding how everything fits together in a real enterprise environment. A couple challenges I'll give as examples. In the beginning, was one of the biggest lessons in the project came from how I started, and honestly how I started it wrong. My instinct was simple: new application means modern stack. So I reached for Spring Boot right away. That's what I'd used before and heard about, and heard that it's productive, and a lot of modern Java apps are built using it. But as the class went on, I realized that mindset completely missed the point of the class, the Enterprise Java. This course isn't about building new greenfield applications. It's about understanding the kinds of systems you'll actually encounter in enterprise environments, including legacy code, older patterns, and infrastructure that doesn't hide complexity behind frameworks. Spring Boot was solving problems for me before I even really understood them, truly understood them, and it includes routing, configuration, dependency wiring. It all worked automatically, but I couldn't always explain what was happening underneath. At that point, I made a deliberate decision to just remove Spring Boot entirely. I even call it the Spring Boot purge in my journal, because it was a huge turning point, the infamous Spring purge. So, rebuilding CodeForge using pure servlets forced me to understand the request lifecycle, filters, session handling, configuration loading, and deployment in a way that I never had to before. Spring does a lot of work, and that's a good thing in the right context. But by removing it, I learned why it exists and what it's abstracting away. By the end, I didn't just know how to use modern frameworks, I understood how enterprise Java works at a foundational level, which is exactly what this class is trying to teach, I am pretty sure. I mean, it is. It's what this is about. Alright, and then, so for another challenge, big one, kind of generic, but it's just configuration, environments, and test isolation without breaking production. The second major challenge was configuration, specifically managing dev, test, and production environments safely. This project forced me to deal with things that are not easy to ignore in smaller apps. Things like database credentials, environment variables, Hibernate configuration, test isolation, deployment behavior, things like that. At several points, one wrong configuration caused tests to fail, deployments to break, or static assets to just disappear. And the scary part was realizing that some mistakes could have affected production data. To fix that, I had to slow down and treat configuration as first-class code. I separated responsibilities clearly. Test databases, state and test resources, production secrets lived only in environment variables, and tests reset the database deterministically before running. I also learned that tools like Hibernate are strict for a reason, even when they feel overly demanding. They force consistency, and if you don't understand how configuration is being loaded, they'll let you know very loudly. By the end, I wasn't guessing anymore. I could explain exactly which configuration was being loaded, when it was loaded, and why. That's not something I could have learned without breaking things first, I don't think. Just because of how I learn things, I guess. And with that, so the biggest thing I learned from this project is how all the layers interact: servlets, services, Hibernate, configuration, and deployment. I also gained a much clearer understanding of how fragile environment configuration can be, and why repeatable tests and predictable setup are essential. If I were continuing this project, and I will be, I don't doubt that one bit, the next steps would be polishing user experience, definitely, expanding evaluation logic. I want to use sandbox instead of just string evaluation, which is very limiting. And continuing to refactor towards cleaner ORM-driven relationships where it makes sense. Now, I'll be honest, this class was easily one of the most demanding courses I've taken so far. Not just in the workload, but in how much it forced me to really understand what was happening under the hood. There were plenty of moments where things broke in ways I didn't expect, where fixing one problem revealed 3 more, and where the only way forward was to slow down, step back, and actually reason through how Java web apps really worked. From servlets, filters, sessions, all the way down to persistence and deployment. But on the other side of this struggle, something clicked. Concepts from earlier classes, advanced Java, persistence testing, even design decisions I'd memorized before, finally started connecting in a way that they never had before, which is amazing to me. And one of my main goals. CodeForge is the result of that process. It's not just a finished project. It's proof that I now understand how pieces fit together, why they're there, and how to reason about them when things go wrong. There's a quote from Steve Wozniak, the Woz, that really captures what this experience was like for me. The goal isn't to make something that looks impressive, the goal is to understand it. That mindset shaped how I approach this project, and honestly how I'll approach every project after this one. Thanks for watching.